noticed that every globe you've ever seen is at a weird angle? That's not just for fashion reasons, like wearing your hat at a fun angle. It's actually because the planet is at the same kind of angle. See, the Earth, the planet Earth itself, is tilted off axis. It's not straight up and down to the sun. We're 23.5 degrees off. And that means that every globe you've ever seen, even comically old ones like this one that my father bought me in 1990 and still has the Soviet Union on it, are tilted to reflect that. Now, what does that have to do with our math this week? We'll get to that in just a second. You see, the Earth being tilted means that different parts of it get different amounts of sun depending on where we are in the year. As the Earth rotates around the sun, sometimes the North Pole is pointed at it, sometimes the South Pole is pointed at it, and the North is pointed away. So we're going to do a really quick visual demonstration of this using this flashlight as the sun, and this Earth as, well, the Earth. Let's take a look. Right now, spinning counterclockwise as it does, the Earth is pointed towards the sun. The North Pole, specifically, is pointed more to the sun than the South Pole. The South is pointing away. So as we rotate through the day, let's find Calgary here, right about here. Right now, the sun is coming up in Calgary, and it's going to stay up for a long time as Calgary rotates past, and eventually, just now off camera, is setting. That's a lot of sunlight for this time of day. I'd say at this point, the sun is probably up for about 16 hours. It's not short. Meanwhile, if we go down to, say, I don't know, let's choose a random spot that we wouldn't ever know anybody in, like Adelaide, Australia. Adelaide here, as it rotates through, let's get the camera adjusted. As Adelaide rotates by, it gets a little bit of sun, and then Australia rotates away again. And that sun's not pointed at it anymore. The sun is probably only up for less than 10 hours, probably more like 8. Over the course of that day, that would be the shortest day of the year for Adelaide, or the first day of winter there, but the longest day for Calgary, or our first day of summer. Now, what happens in 6 months? Well, we'll see that in just a sec. Now, 6 months later, the sun hasn't really moved, but the Earth has. So we're still spinning counterclockwise, and Calgary's still the same spot on the planet, but it's up here now, and it's pointed away from the sun. So as the Earth rotates, Calgary is still dark, still dark, still dark, still dark. There's the sun. Sunlight up for probably about 8 hours, and then sets again as it spins away. And you might notice that on this day, the North Pole is pointed away from the sun, and it's actually completely in the dark. It's past my hand here. The sun doesn't come up at all at the North Pole on this day of the year. Just like in our last example, the sun would never have risen at the South Pole. There are places on Earth that don't get any sun for a whole day every year. And actually, it's more like a few days, because the sun just kind of bounces along their horizon for a little bit there. So, let's take a look at Adelaide. There it is. Oop, adjust camera. There it is. Now, as Adelaide spins by, it's getting the same treatment that Calgary did on our longest day of the year, on our first day of summer. So the sun's going to come up. It's going to stay up for about 16 hours as Adelaide is pointed towards the sun for a lot of time this day. And then the sun is eventually going to set as it spins away. Let's take a look at a picture to help this make a bit more sense. So as we look at this picture, we can see that the Earth spinning around the sun counterclockwise and spinning itself counterclockwise means that different parts of the planet are pointed at the sun different times each year. I'm not sure if you can see my mouse right now, but right here on the summer solstice for the northern hemisphere, the north half of the planet, the North Pole is pointed and in direct sunlight the whole day. The sun doesn't go down. And the closer you get to the North Pole, further away from the equator, you will be seeing more and more sunlight for that period of time. Meanwhile, south of the equator, the South Pole is pointed completely away, and the closer you get to the equator, the shorter your day, or the longer your day is going to be. The equator actually gets the same amount of sunlight all year round. The sun is up for about 12 hours, no matter what time of year it is in the equator. It'll fluctuate by a couple of minutes, but not very much. The North and South Pole are complete opposites. When the sun is up all day at the North Pole, it's down all day at the South. There are two other parts here, March 21st and September 23rd. We call these the equinox. They're called that because it's equal. Every single place on the planet gets the same amount of sunlight that day. Those are the days when everything is equal. Everything is pointed at the sun the same amount of time because we're halfway around our turns. We actually just passed one of these on March break. March 21st is the vernal equinox, the first day of spring. Now, on this day, Adelaide and Calgary are going to get the same amount of sunlight. But now, the South Pole is entering its fall as the North Pole enters its spring. So, the days are going to keep getting shorter and shorter and shorter, where Mr. Cutts is in Adelaide, while our days are going to get longer and longer and longer until they finally peak at the summer solstice, our longest day of the year and his shortest. His longest day of the year and our shortest is December 22nd. That's actually one of the reasons that festivals like Christmas are when they are. They're to celebrate the sun coming back because it's been a long time since we've seen it. Okay, now the math part. So this week we're going to start preparing data for a graph we're going to make next week. We're going to be graphing the change in seasons between Adelaide and Calgary and looking at the comparisons as they enter the fall and we enter the spring. Now, right now, I'm looking out my window and it's pretty snowy out there, so we might not see too huge a shift right now. It might be a bad week for it, but what the heck, let's give it a try. If you go to D2L, you're going to find a template for collecting a few days' worth of data for both cities. Once you've filled that out over the course of this week, we're going to be using that data next week in creating a graph. So be ready for that. Make sure you've got that collected because you're going to need it for next time. See you guys. Bye. Oh, hey, one last thing. Quick shout out to Mrs. Ramsey for requesting that I put more star wipes in these videos. If the editing is a little bit obnoxious to you, blame her. Thank you. Bye.